Okay. All right, welcome back to Algebra. Today we're going to get started on section 3 and our next specific type of sequence and series. This one's called geometric. We spent yesterday talking about arithmetic, and now today we're going to talk about geometric sequences and series. So we'll start with the definition. Geometric sequence is a sequence in which the ratio of consecutive terms is constant. All right? Now, when we say the word, let me highlight it in red here. When we say the word ratio, of course, since elementary school, we've been talking about ratios. But the way we're going to consider our ratios, we're not going to use the word to like we would have in elementary school. We're not going to use a colon like we may have in junior high school. What we're going to do instead with our ratios is create fractions. All right? And think of that fraction kind of as being the operation division. Okay? All right, so it's a sequence in which the ratio of consecutive terms is constant. Constant, again, doesn't change. And we give a special name to this ratio that doesn't change. And not probably a big surprise, it's called the common, because it doesn't change, ratio. And we traditionally use the letter r, a lowercase r, to represent it. All right, so let me give you guys some examples of some geometric sequences. Feel free to pause the video if you want to jot a few of these down into your notebook. My number one is a geometric sequence because if we take the ratio of any of the terms, we'll always get the same value. As an example, if I take 162 and divide by the term that comes before it, that's exactly the same as taking 54 and dividing by the term that comes before it, or taking 18 and dividing by the term that comes before it, or taking 6 and dividing by the term that comes before it. Every single time we get the number 3. It doesn't change. It's always the same. It's always 3. So what we'll say is that the common ratio for that sequence is 3. All right? My second example is also geometric because we take any of the terms and divide by the one that comes before it. 112 divided by 56. 56 divided by 28, 28 divided by 14, 14 divided by 7, no matter which division you choose, you always get the same value, you get 2. My third example is also geometric, 768 divided by negative 192, negative 192 divided by 48, 48 divided by negative 12, negative 12 divided by 3. No matter which pair of consecutive values you pick, you always get the same thing, you'll always get negative 4. My fourth example is a little bit tougher to see, but it too is geometric because you take any one of the terms and divide by the one that comes before it, any of them, and I'll pick a nice easy one like 2 divided by 4. Of course, that's reducible to a half. We'll always get the same thing. And feel free to try any of the others. Now, my fifth example is going to not be geometric because we don't get the same value every time we take a ratio. 144 divided by 72 is 2, but 72 divided by 24 is 3, then 24 divided by 12 is 2, then 12 divided by 4 is 3, then 4 divided by 2 is 2. We don't get the same value every single time, therefore that one is not geometric. Okay? All right, now just as we had with arithmetic sequences, we're also with geometric sequences, we're going to have a formula that helps us in several ways. So this is a real important formula you need to make sure you get into your notebook. It's the formula that allows us to, at least initially, jump to any term inside of a geometric sequence. And so what we've got on the left-hand side is a sub n. So this allows you to find the nth term in a geometric sequence, so the 10th term or 15th term or 34th term, whatever term you guys want to go to. And what that's going to be equal to is A1, which is the first term in the sequence, multiplied by R, which is the common ratio, raised to a power of n minus 1. And what I need you to notice, and I'm going to choose blue so I can highlight it, whatever term number we're looking at, the exponent is going to be 1 smaller. So if we were to be looking at the 10th term, then this power would be 9. If we were going to look for the 17th term, then this power would be 16. All right? The term number and the power are always 1 apart. So whatever the term number is, the power is 1 smaller than that. Okay? And what that allows you guys to do then is, given a sequence like 2, 6, 18, 54, if we wanted to or needed to, we could jump to the 14th term. How? By taking the first term in the sequence, 2, and then multiply by the common ratio. How do we get the common ratio? Take any one of the terms and divide by the term that comes before it. So the common ratio here is 3, raised to a power that's 1 smaller than the term number. So if it's the 14th term, we'd have to then raise that to the 13th power. And these are going to be pretty big numbers. So I'm going to use my calculator. Remember, we do the exponent first. So we'll raise 3 to the 13th power, and then multiply by 2 seconds. So exponent first, multiply second. And what we get for the 14th term then is 3,188,646. All right, we're able to jump to the 14th term. Let's try another one of those. Here's another example where I give you a geometric sequence, -3, 6, -12, 24, -48, and while we're at it, let's just talk it through. Take any one of the terms and divide by the one that comes before it. We always get the same doggone thing. We always get -2. So to jump to the 11th term, what we do is we start with the very first term, which is -3. Then we raise that, oops, sorry, I forgot to put that in parentheses. Remember, anytime we put a negative number into a formula, wrap it in parentheses. Sorry, I almost forgot that. Then multiply by the common ratio. Same thing there. Anytime we put a negative number into a formula, wrap it in parentheses. And then raise that to the 10th power. Why 10th power? Because whatever term number we're looking for, the power is 1 smaller than that. And then just use your calculator. Remember, do the exponent first, so -2 to the 10th power is 1,024, and then multiply by -3, so we'll get -3,072. So the 11th term would be -3,072. All right, and I've got one more of those, one more example. Feel free, as always, pause the video if it's going too fast for anybody. But again, we've got a geometric sequence, 12, 6, 3, 3/2, 3/4. Please notice the common ratio here would be 1/2. Take any one of the terms, divide by the one that comes before it, we get 1/2. So if I wanted to jump to the 14th term, what we do is we start with the first term, 12. We then multiply that by the common ratio, 1/2, raised to a power 1 smaller than the term number. So if it's the 14th term, we have to raise to the 13th power. And so what we'll have then, guys, is 1/2 raised to the 13th power. And I'm actually going to write this one out this time, just so everybody can see it. It's going to be kind of an ugly fraction. It's going to be 1 over 8,192. And then I believe, if I'm doing that right in my noggin, we could cancel a 4 top and bottom. So we could cancel a 4 top and bottom, and we'd be left with 3 over 2,048. So the 14th term would then be this kind of crazy fraction, 3 over 2,048. Okay? So I'm going to ask you in your assignment to practice with some problems where we ask you if it's geometric or not. We're going to ask you to also be able to jump to some term in a sequence, like this one says the 14th term. And then we're also going to use the formula a little bit differently. So a different question we're going to ask you guys to do is this one. Find the equation for the geometric sequence given the terms. Okay, so, or given some information about the terms. So if, as an example, if I gave you 3, 12, 48, 192, and so on, could you guys get to the equation? So what I want you to do, need you to do, is I need you to be able to start with our formula, a sub n equals a sub 1 times r raised to the n minus 1 power. And what I'm going to need you to do on all these problems where we ask you to find the equation of the geometric sequence, I need you to find two numbers. I need you to find A1 and I need you to find R. I need you to find A1, the first term, and I need you to find R, the common ratio. Now in the given problem, can you find both of those fairly easily? Well, I hope you can find A1 really easy because it's the first doggone term. What's the first doggone term in the sequence? 3. And then the second thing I need you to find is R. But how do we find R? We take any one of the terms and divide by the one that comes before it. So take as an example 48 divided by 12, and what we'll get is 4. So the equation for the geometric sequence would be a sub n equals 3 times 4 to the n minus 1 power. I need you guys to find two values, a1 and r. So let's practice that a couple more times. Here's another geometric sequence, and what I'm going to have you guys do is find the equation. So I'll start you off with the entire formula, I should say. A sub n equals a1 times r raised to the n minus 1 power. And again, two things. Can you find a1 and can you find r? Well, a1 again is just the first term. There it is. It's 36. And r we get by taking any one of the terms and dividing by the one that comes before it. So as an example, to get r here, I could take 4 and divide by negative 12. Or if you don't like that one, negative 12 divided by 36. But no matter which one you pick, what you get for r is negative 1/3. Now, because that's negative, when we put it into our formula, remember to wrap it in parentheses. And so our equation then for the geometric sequence would be a sub n equals 36 times negative 1/3 to the n minus 1 power. All right? And now let's make them a little bit tougher. Two more examples, and then we'll call it a day. All right, two more examples. This time, I'm going to give you a little bit different information, but ask you for the same thing. Find the equation for the geometric sequence. So we start with a sub n equals a sub 1 times r raised to the n minus 1 power. And again, two values we need, a1 and r. And with the given information, do I tell you either part of that? Well, heck yeah. I tell you what r is right off the bat. I don't tell you what the a1 is, but I tell you the value for r is 5. So we can immediately replace r with 5. But I don't tell you the first term. I do not tell you the first term in this problem. I tell you what the third term is. So how can we work ourselves back from the third term to the first term? Well, you could just kind of work it out with a calculator, but I want to show you a method that works for everything, ones that aren't quite so obvious. What we do, guys, is we take the formula, a sub n equals a sub 1 times r raised to the n minus 1 power, and what we're going to do is we're going to replace a sub n with a sub 3. And we do that because we actually know what a sub 3 is. A sub 3 is 625. Now we don't know what a sub 1 is, but in this problem we know that r is 5, and we know what this power is. We know what the power is on the r because the power is always 1 smaller than the term number. So if this is the third term, the power must be 2. Power must be 2. And that leaves you with just one variable to solve, and what's that variable? a1, which works out great because that's the other variable I need for my equation. So I just have to do a little bit of work. 5 squared is 25, and to get rid of times 25, I'd divide by 25. So a1 is equal to 625 divided by 25, which turns out to be 25. And so my entire equation for the geometric sequence then would be a sub n. A sub n is equal to 25 times 5 to the n minus 1 power. Okay? And we're going to do one more. I'm going to do one more that's a bit tougher, but the same directions. Find the equation of the geometric sequence given these two pieces of information. Again, we're going to need two numbers. We need to know what a1 is, and we need to know what r is. All right? Those are the two things we need. Now this time I don't tell you either one of them. I don't tell you what r is. I don't tell you what a1 is. So how are we going to figure them out? Well, what we're going to have to do is take our geometric sequence formula and apply it to a sub 4. Okay, so I'm going to take this a sub 4 and write what it's equal to. Well, it's going to be equal to a1, which I do not know, times r, which I do not know, raised to what power? Well, remember the power is always one smaller than the term number, so if the term number is 4, the power is 3. And then what I'm able to do, guys, is I'm able to actually replace a sub 4 with what it's equal to. A sub 4 is actually equal to the number 48. Now, all by itself, that's one equation with two variables. The two variables are a1 and r. One equation, two variables, bad. Can't solve. So what I have to do is the same thing for the second piece of info. I have to take our formula and replace a sub n with a sub 7. That's then going to be equal to a sub 1, which I do not know, times r, which I do not know, raised to the 6th power. 6th power because the power has to be one smaller than the term number. Then I get to replace a sub 7 with what's actually equal to, which is 384. And again, all by itself, I can't solve this equation because it has two variables. But I have to think of these two being together then, and together I'd have two equations with the same two variables. Ding, ding, ding. I can solve that. Now I need to give you a little bit of a heads up because of the multiplication. In fact, let me go back to my laser pointer. Because of the multiplication here and the multiplication here between the a1 and the r, between the a1 and the r, elimination's not going to work. Elimination can't work. So instead what will work is the other basic method you might remember, which is substitution. So what I'm going to choose to do is solve this equation for a1. And to get rid of this multiplication, I divide. So I'm going to divide both sides by r to the third, so that on the right-hand side, the r to the thirds cancel. And a1 is then equal to 48 divided by r to the third. Then wherever I see an a1 in the other equation, which is right there, I can replace a1 with what it's equal to. So I replace a1 with 48 over r to the third. And by making that substitution, now we only have one variable. It's in two different places, but I only have one variable left, and that's the r's. So I'm going to be able to solve this fella. I just need to do a little bit of canceling. The 3 r's in the denominator will cancel with 3 out of the 6 r's out front, or out back, I should say, leaving me with 3 r's. Then I can get rid of times 48 by dividing by 48. And I need my calculator for that one so I don't get it screwed up. So 384 divided by 48 is 8. And then to get rid of the power of 3, we do the inverse, which is to take the cube root of both sides. So r then is going to be equal to 2. So it took us a long time, but we found the common ratio. The r value is 2. So I can slide that into my answer. Now the other value I need is a1, and you might think, holy smolies, I've done a ton of work and I'm not done. But we have an equation over to the left that already says a1 equals. So that's a great place to go, and now what I can do is replace r with what it is. R is 2. So if I replace r with 2, I can then solve for a1. Because 2 to the third is 8, and 48 divided by 8 is 6. So a1 then, I can slide that over if you want me to arrow it all the way there. And we now have our equation for the geometric sequence. A sub n equals 6 times 2 to the n minus 1 power. Okay, easy? No, I don't think so. Kind of some tough problems there. All right, I'm going to stop this video so that you guys can take a little bit of a break. And then we'll have a second video that takes a good look at geometric series. So you have a second video for this section. Okay, so talk to you again in a little while. Bye.